All right, let's talk about number 11. So this is a regular what? What shape is this?
Polygon.
Yes, it is, but more specifically.
Six hexagons.
It's a hexagon. All right, so this is a hexagon, which means we've used hexagons in a couple of these, and we're going to use hexagons more often than not because they make what kind of triangle when you draw this right here?
Right.
They all make a right triangle, good, but they make a special one. Yeah, so they make a 30, 60, 90 right triangle. So that's why we will use hexagons more than we'll use probably any other shape when we're doing this. Okay, so you know that this is 18. In our special right triangle, if this is S, this is what? 2S, and then this is S square root of 3. Good. Okay, so if 18 is equal to S root 3, I need to figure out S. So how would I do that? If S root 3 equals 18, then how would I get S by itself? No, you don't have to do that. Divide by, well, I want to get S by itself, so divide by root 3. Divide by root 3. And you can do this a couple different ways. You can do it on your calculator and get a decimal, or you can write it in math print mode, and then it gives you a simplified radical. I don't really care which way you do it. I'm going to do it in a simplified radical form. So it ends up giving you 6 root 3. So this right here is 6 root 3. Which means if this is 6 root 3, what's the whole thing? If this is 6, what's the, 12 root 3. The whole side then is 12 root 3. So if one side is 12 root 3, how can you figure out the perimeter then? Add it how many times? 6 times, or you can multiply it by 6. What's 6 times 12? 72. So then the perimeter is equal to 72 root 3. Okay? You can do that to get the perimeter, or if you don't remember your special right triangles, I know all of you do, but if you don't, you can do what Tierra said, which is use SOHCAHTOA. Okay? So if you use SOHCAHTOA, then this is opposite and this is adjacent, so what measure would you be using? Opposite, not SOA, but TOA. So tan 60 equals 18 over x. I know. It's okay. I don't correct people when they do that because it doesn't matter to me if that helps you remember, but it's actually sine, cosine, tangent. SOHCAHTOA is just a way to like remember the letters. So I don't care if people write TOA 60 or SO 60 or whatever. It doesn't matter to me as long as you know what those trig ratios are. Okay, so this would do this whole thing too, except it would give it to you in a decimal form. It doesn't matter to me what you do. If you think this is easier than remembering the special right triangle, then use it. And you're going to use tan pretty much every time, okay? Because if you were looking for this one and had this one, you still would use tangent. So if it's easy for you to use tangent, then by all means do that instead of the special right triangle. Okay, so if that's our perimeter, this is our, what's that A word again? Kind of sounds like apostle, but apothem. It's the apothem. And the formula is area equals 1/2 apothem times perimeter. So in this case, area equals 1/2 18 times 72 root 3. So what's 1/2 of 18? 9. So we're going to do 9 times 72 root 3. 72 times 9 is 648. So the whole thing is 648 root 3. These regular area ones are long problems. There's not really any bones about it. It's a lot of work, but what I'll tell you is as long as it's a hexagon, you know this angle is what? 60. So as long as it's a hexagon, you can memorize that. If it's a pentagon, it's 54. I can give you guys a list if you want of what all the angles are. Do you want that? Yeah. Okay. All right. I'll make a list of all the angles so that you don't have to do it. Okay? So I'll get you a list of that before your quiz, which is going to be tomorrow. All right? Just FYI. Yeah. Quiz on 7.1 to 7.3. So this is one part of it. Most of it is find the area of this triangle. Find the area of this. Find the area of a composite shape. So you guys will have a formula sheet too. Triangle. Trapezoid. Area of regular polygons.
It says I have it
here, Miss, is missing.
Because you didn't turn your homework in?
It's right there. I just
You
looked
did?
at it.
Okay. Yours isn't a 4. Is it? Oh, I know you turned yours in. I'll change. Maybe I might have marked them. It might have filled in ones it shouldn't have. I'll check. Okay, because I have both of yours. Okay. All right, so this is like one section of it. We're also going to talk about composite figures, which we talked about a little bit a couple of days ago. A composite figure is made up of simple shapes. So we can't use the area equals 1/2 apothem perimeter for this because this is not a regular polygon. So I think, Miguel, you might have said it a couple of days ago, but what can you do to find the area of this shape? Because it's not a shape that we know. So what could you do?
We're gonna make it a shape you do.
Yeah, make it into a shape you do know. So you've got a couple options, but where, like if I were to split this, where do you think you should split it?
Right there.
Going horizontal or vertical? Horizontal? Okay, right here. You could also do it vertically right here. You could also do it diagonally right here, but that would give you 2 trapezoids, and I think that would be don't use that word, but I think that makes it more work for yourself because those are longer formulas. Okay, so then what's the area of this shape? It's a rectangle. What's the base? 15. What's the height? 12. So how would you find the area? Okay, so what's 15 times 12? 180. 180. All right, what about this one? Tiara, say that louder. So I agree that you're going to subtract. Yes. Why are you subtracting 21 and 12? Tiara?
Because, okay, you need to get that side.
I need this side, right?
So you got to, because 12 at the top.
Good. This is 12. This whole thing is 21. So then for that to be 21, this part would have to be 9. So then you would have to do what? 27 times 9, which is 243. And then to finish this, what would you do? Add it, and that gives you
3, 8, 9, no, it's 4.
423. 423. What's our unit? Why is it cm squared? Good. Whenever it's area, it's cm times cm, so you do cm squared. If it's volume, it would be cm cubed. Good. Okay. All right, what about this one? This one's already split for you, but what are our shapes?
Triangle.
It's a triangle, rectangle, and a half of a circle. So,
It's called hemisphere, right?
yeah, semicircle, hemisphere. All right, so which one do you want to do first?
The rectangle.
The rectangle? Okay, I mean, we can. Probably not. We have a little work to do. What do you have to, well, let's look at the triangle first. Okay, I know that this is 10.2, but that's not really going to help me because this is what part of the right triangle? The hypotenuse. So I need the base and the height. Do I have the height? I can figure out the height, right? Because this is 7.8 and this is 3, so the height must be 4.8. So then how could I figure out the base? A squared plus b squared equals c squared. Or, yeah, I guess that's all we could use. Okay, so a squared plus b squared equals c squared. So somebody with a calculator, what's 10 squared? 10.2 squared, sorry. 104.04. And then what's 4.8 squared?
23.04.
All right, so now what do I do?
You add two things. Subtract it, and then you got to square with it.
All right, so that gives me 81 equals b squared. So what's b? 9. Good. So then the base of our triangle is...
Ooh, that's mental math. I'm trying to tell you.
So then the base of our triangle is... Which means the length of our rectangle is also 9, which means the diameter of our circle is also 9. Good. Okay, so that's going to give us pretty much everything we need. So how do I find the area of the triangle then? Base times height divided by 2. So I'm going to do 4.8 times 9 divided by 2. 43.2. 21.6. All right. What about my rectangle? 27, because it's 9 times 3. And then what about this semicircle? Do the area of the circle, which is what? Pi r squared. And then how much of a circle is this? Half. So what would you do? Divide by 2. Perfect. And what's the radius? Why is it 4.5? Good. So I need to do 4.5 squared times pi. Because if the whole thing is 9, the radius must be half of it. So 20.25, and then you did that times pi? 63 point what? No, you're right. 63 point... I'm going to do 6.2. I think we just rounded at different points. Okay, and then what do I have to do with this? So then that's going to give me... Good. And then how would I finish? Add it all together. Okay, so 20, 40, 70... 9, 80.4, roughly 80.4. All right, and what would my unit be? Good. So composite shapes is literally just putting together everything that we've done. Do not forget the Pythagorean theorem. Okay, what kind of shape is this?
Two right triangles.
Yeah, it kind of looks like a what?
Envelope.
It kind of looks like an envelope, but you're looking for the shaded part. So it's like the whole shape is a what? Rectangle, but then they took out what? The lobe part of the envelope. So they took out the lobe part, which is, what shape is that? That's a triangle. Okay, so they're taking a rectangle. So you're going to find the area of the rectangle, and then what are you going to do? Yeah. So I know it seems kind of like redundant to write that. I still as an adult do that, like rectangle minus triangle, so I can keep track of what I'm doing, because so often we get stuck just adding everything together, and people will often just add it because they don't think about it. So just take a second and think about what you're actually going to do. And if that's mental, that's fine, but just think about what you're going to do in the problem. So what do I have to find first? So the rectangle here is, which would give me, all right, and then how do you find the triangle? Well, the height is 9. What's the base?
Yeah, I'm gonna say that. Oh, 30 feet.
Yeah, so we do have the base, so it's 36 times 9. 36 times 9. 1. Okay, so something, and then you divide it by 2 and got what? 324 divided by 2 is 162. All right? So it's 162. So then if I subtract those, what do I get? 4, don't act like you just did that. All right, 486. What's my unit? Meters to the second power. Meters squared. Okay, so what's the difference here? You had to subtract. How can you tell when you have to subtract?
Because you're going to have something that you don't need.
Yeah, you're looking for a shaded region that you don't need the unshaded region. So you've got part of the envelope, but not the whole thing. Okay, all right. How would you do this one? Just tell me what your shapes would be. We're not going to actually do it. Tell me what your shapes would be. Your shapes are a circle and a rectangle. It's going to be rectangle minus a circle. And they're half circles, but if you put them together, they make a whole circle. So you don't have to do like minus 2 half circles. Just do minus the whole circle. Wait, like a what? It looks like a basketball court to me.
It looks like it's a big.
Oh, yeah, like a air hockey table. Okay, I can see that. Yeah.
For the hot pockets.
I guess we know where your mind is, but yeah, it does. I understand. And then you fold them down so you can just eat it. That's true. All right. Okay, go do these 4. Huh? No. You asked that. All right, so for all of these except for D, I would have added them together. D is the only one that I would have subtracted on because I think it's easier to just find the whole rectangle and then subtract. For the rest of them, I mean, you could add, but then you'd have to find the area of 2 triangles as opposed to just one. Okay, so how would you find the area of this figure? Count the squares. So 1, 2, 3, 4. Yeah, okay, so when you're doing these problems, first of all, it's all estimating because there's not an exact way to do it since it's curved lines, but you basically want to try to put together the ones that are halves. So for example, this one, these two together would make about 1. This side would be about 1. Okay, this would be about 1. Would this be 1? No. Maybe like 1.5 maybe, so if that's 1.5. So then all together you've got 1, 2, 3, 4, 5, 6, 7, 8.5, like roughly 8.5. Here's the deal with these. If you're close, I mark you right. Because I mean, unless you put like 622, like you're literally just counting. So don't make these harder than they are. I would probably accept anywhere between 7 to 9 on this one. Yeah. Like that's the range of answers I would accept. Yeah. Like 8.5 is the answer, but it's not exact. But yes, that is all you're doing. Okay. All right. You can also do it like this, where you split them into recognizable shapes and find the areas of those. I wouldn't bother. Okay. Yeah, 8.5 is the answer. This will get you pretty close to 8.5. It might be a little bit more exact, but as you can see, it's still not perfect. So the amount of work this would take compared to what we just did, the payoff is not there because you're still not getting an exact answer. So on any of these, my recommendation is just to estimate. Take your time, but don't spend like an hour on them. If you're close, I'm going to give it to you. Yeah. Okay, so I'm not even going to have you do this for a practice because we're kind of low on time. So I just want you to do the exit ticket here. In number 2, though, no, you're doing it. All right, in number 2, you're just finding, this is the shaded area. Yes? What? Okay. All right, so the shaded area is like the blue leftover stuff.